So we're going to be handing out USB keys to everybody that has the VM images. Madhu, do we have about 70 of these left, or? Yeah. Yeah, actually, if you need a USB key, you don't have the images, raise your hand maybe, and we'll pass them out. Yeah. Yeah. Yeah, and then once you, actually, it looks like a lot of people already have them, but we'll pass them out here. We'll get them around. There we go. He's tossing them. So we'll kind of wait till everyone gets a USB key here, and then we'll get started on this as well. There's a couple of seats up front here if people, if anyone wants to come and sit down up front. You don't have to be shy. Ryan doesn't bite. He's okay. You never know. Okay. Okay, so we'll kind of get started here. I usually like to wander around when I talk, so this is going to be difficult for me to just stand here, I guess, a little bit. But so welcome to the second. Oh. This is better. Okay. So welcome to day 2 of the OpenDaylight Summit. It's kind of interesting that they put this tutorial right away in the morning on the second day after the party last night. So, but this will be pretty good. So hopefully everyone's here to learn about using OpenStack with OpenDaylight. So the team of people that have been working on this have been working on this for quite a while now. So hopefully everyone gets a good idea of this. I just put 4 of the names of the people that are going to be helping out as we're going through this. These three people will be doing that. So actually, Ryan, could you raise your hand so everyone sees you? Brent and Madhu, you guys are at the back, right? Raise your hands. So if people need help as we're going through this, these guys are going to kind of wander through and we'll be able to assist people with things as well. So, okay, let's see. Let's jump into things here. Okay, so this is kind of what I hope everyone walks away with from this presentation as well afterwards. So actually, first of all, a show of hands. How many people have experience with OpenDaylight? How many people have brought up OpenDaylight a little bit? Okay, so that's not bad. How many people who raised their hands brought it up yesterday during a tutorial for the first time? Okay, so there's not a lot of experience there. Okay, what about OpenStack? Does anyone have, how many people have experience with OpenStack? Okay, so there's a good experience. So this tutorial will be somewhat high level, I think, depending upon, but you can go deeper if you want as well. So we're going to give everyone experience bringing up OpenStack, OpenDaylight on Fedora, Linux as well. That's what the VMs that are on the USB keys have as well. We're also going to give people experience bringing up a multi-node OpenStack environment using DevStack. And then hopefully you get some experience seeing how the two of them integrate together and how OpenDaylight is able to orchestrate virtual networks for OpenStack Neutron as well. Okay. So really this is as simple as it gets right now. We're going to have 2 VMs. One of the VMs that you're going to use will have OpenDaylight running in it, as well as the OpenStack control software and OpenStack Compute, Nova Compute on it. And the second VM will just be running Nova Compute as well. And this way we'll be able to see the tunnel network set up for the tenants and everything like that. So, okay, everyone has the USB key? So let's plug them into your machines and copy the files over. The other thing you're going to need is either VirtualBox or Fusion or Workstation or KVM or something like that.
There'll be 2 folders in that stick. This tutorial is for on the DevStack only.
That's a good point. You can hold on to that one. I'll stay up here. Okay, so I'm going to try to do this as, whoa. Interesting. Ah, there we go. That worked. Okay. So I've actually already copied these over. So we'll go through this kind of slow to make sure that everyone gets that. I'm going to boot the control instance first that I have here. So this will boot relatively quick here. So everyone else, is everyone else booting their control instances as well? Yeah? Okay. So this is up. Going to log in as, the login information for this, by the way, the username is ODL and the password is ODL as well. And it is set up for sudo access as well. So I'm just going to take a look. So in my case, yeah, this one was already configured as well. Okay. So how many people have their control instances booted up already? No one? A couple people? Okay. How many people are still copying the images off of the USB keys? There's a lot. Okay. Login is ODL, and ODL is the password as well. Just a sec. Let me bring up the slide. I think there's, yeah. I'll leave that up for a sec. So that's actually, wait a sec. That's actually incorrect.
And for those who have trouble copying the image over, the USB has been formatted with exFAT, so you may have to install that driver.
For which operating systems?
I mean, XP doesn't support it. Yesterday we saw that, and it has problem with Ubuntu now. So. Yeah.
Oh, Ubuntu had a problem as well with? Okay.
Yeah.
Okay. Okay. Yeah, if anyone's having trouble or anything, raise your hand as well, and we'll get someone over. Hey, Brent, could you? Got it. Thanks. Okay, so maybe while we're waiting for everyone to copy the images and bring up the control node, let me go back to these slides over here as well. So logistically, where is this right here? Okay, I can't wander around now. This is a high-level slide of what you're going to have to change on the OpenDaylight slide image as well. So as you can see here, we've put OpenDaylight in the image as well, and it's the released virtualization edition of Hydrogen as well. Inside the ODL directory, there's an ODL directory and then an OpenDaylight, and inside there's a configuration directory, and there's a config.ini file as well. Okay, that's a little. Okay, so one of the configuration items that you're going to want to deal with is the OVS DB support that's in OpenDaylight supports both OpenFlow 1.0 and OpenFlow 1.3. And I think that this was discussed yesterday at one of the sessions, although Madhu will correct me if I'm wrong, but I think, did you discuss the a little? Okay. I mean, at a high level, the differences are OpenFlow 1.0 will set things up to look exactly like the Open vSwitch Neutron plugin, or the ML2 Open vSwitch mechanism driver as well, where you will have two bridges on the host, a BR-int and a BR-tunnel, and you'll have patch ports between the two and things like that. OpenFlow 1.3 does things a little bit more intelligently. It uses a single bridge and it uses multiple tables on the bridge to handle the tunnel traffic. So that's a configurable option in there as well. And then there's also, you can configure an IP address if you have like a multi-homed host as well. You can set that up in there so OpenDaylight will bind to a specific interface as well. If you log in as ODL, there should be an ODL directory, I think. And then in there is, or is it, do an L, hold on a sec, I'll do this. Did you find it? Actually here. If you see here, so I'm logged in as ODL, so there's actually an ODL directory in there. I think this should be pretty readable. So inside OpenDaylight, that's the unzipped released version. Yeah.
How do you increase the font?
Yeah, actually, hold on. I'm going to actually do this. There it is. That's a little better, Madhu? Yeah?
Yeah, seems okay.
Wait a sec. I just need to see what that IP address is. I'll log in from over here. There we go. Yes. 133. Yeah, there. Okay. This should be a little bit more readable. Okay. So you can see in this directory here where the OpenDaylight would be untarred if you download, or unzipped if you have it there. There's the configuration, and then there's a config.ini file. So inside of this is where you'll see the version. So it defaults to OpenFlow 1.0, the OVSDB support inside of OpenDaylight. You can uncomment this to do 1.3. I think that this is actually uncommented by default. I think, is that correct? Yeah. Okay. Thanks for verifying. So then there's a run.sh lowercase script here as well, which actually is what is used to start OpenDaylight. I've actually created a capital run.sh that actually has both versions as far as the command line parameters to start this. I think that this should be, you want to make sure that this OpenFlow 1.3 is uncommented. Yeah. Did you have something to do or no?
No.
Okay. So once you do that, then we can go ahead and bring up OpenDaylight by running this. And so then we'll let this will spin for a second as it boots up. So just a show of hands, how many people are at this point as well? Is anyone here, or are people still copying things over or bringing up VMs? Okay. A few people? Yeah, 1.3, leave that one uncommented, yeah. And then make sure you also have in the configuration, config.ini, the 1.3 uncommented as well, yeah. You can change those. I think Madhu was saying that by default, it's fine to leave it on and let it bind everything at this point, yeah. Otherwise, you could set it up to be the second interface. So the way that the VMs are set up, depending upon if you're using VirtualBox, Fusion, or Workstation, the first interface on the VMs is typically going to be the NAT interface, so it'll be NATed. And then the second one is set up as a private network on the host. So typically that's what we'll use for this communication, but either way it'll work.
Just in case, right, for VirtualBox, we had some problems yesterday when we were running this demo.
Okay.
So try to avoid NAT as your any communication for it, right? So just use, if you can create two host-friendly networks on a VirtualBox and use only host-friendly networks for this.
Yeah.
Don't use NAT.
Don't use NAT.
Don't use
So if you're using VirtualBox, don't use NAT.
And you create them under preferences in the global config, not in the actual VM itself, just in case anybody's fresh to VirtualBox.
That's for VirtualBox, Brent, or?
Yes, sir.
Okay. Okay.
We learned painfully yesterday.
You learned painfully. Hey, do you guys know the simple forwarding bundle is out of this, right?
Right.
Okay, good. So we don't do that. Okay, so once this is up, it should be running again. So we can look at the bundles that are running. By doing an LB command, we can look for the OVSDB bundles as well. And you should see 3 of them, the OVSDB, the Neutron one, and then the northbound API one as well. So has anyone made it to this point yet for the tutorial? A few people? Does anyone need help or is stuck at anything at this point? If anyone's stuck, feel free to raise your hand and we'll get someone over to help. Okay, yeah. Actually, just for my own curiosity, how many people are using VirtualBox? How many people are using Fusion or Workstation? Anyone? Just a couple? Okay. Madhu, stop laughing. Okay. Okay, so see if we get. We'll wait a sec to see if other people come up to this point. I'm going to log in over. I'm going to increase the font size here as well. Just a sec.
Oh, you can have this. Here, you want it? The same box.
For folks that are trying to do VirtualBox under Windows, you may run into some fun issues with the amount of memory that this thing wants, as well as VirtualBox not wanting to let you at the host-only interfaces. So you might have to play around with it a little bit.
Did you figure that out here, or you're still?
Struggling with it.
Okay. So Ryan will update for people running Windows with VirtualBox a workaround here. Actually, I should note too that these VMs do require a fair bit of memory as well. So if you have 8 gig of RAM on your laptop, and 8 gig or higher, you should be okay with booting these. But if you got 4, yeah, it's not going to work because. Well, the fact that we're running all of the OpenStack control software as well as OpenDaylight in the single VM, yeah, it's fairly memory intensive at that point, yeah.
Start because it's using so much memory.
Yeah. Okay, yes. Okay, yes. Log into the VM? Okay, let me log in here. Okay. Did you want to see the? Gotcha. Okay. So the way that we got from here, logging in, to here, having OpenDaylight running in the VM. So we went into the ODL directory, and then if you do an ls in there, there's an OpenDaylight directory as well. So then we're going to go into the OpenDaylight directory, and if you do an ls to look at the files, you'll see a configuration directory. I don't think that anyone should have to modify these files. I was kind of showing in an example. They should be set up for OpenFlow 1.3, and they should be set up to bind to all the interfaces on the host, so that should be okay. But the only thing I'm not sure about is this capital run.sh script. You may have to uncomment the 1.3 and comment the bottom one out. I think it may be reversed. Just make sure that that's set up that way.
Yeah, this is very important.
Yes.
If you don't have this one, then nothing's going to work for you guys.
Right.
So, yeah.
Because you have to either go all 1.0 or all 1.3.
Right.
Yeah.
Yeah.
Yeah. Okay. Okay, so we'll see. We'll wait a sec here to see where people are at with that. So how many people have the controller up and running in their VM now? A few people? There's a couple people that have it up and running. Okay.
Just a note to all of you here, right? I mean, not everybody might get it working today because that's the reality of DevStack. We have spent weeks to get it working. So don't feel bad if it doesn't work. Now just look at the video it's been recorded and go through this tutorial later point of time and get it working.
Yeah, and I think the other thing to note is that, I mean, this should work if your laptop has 8 gig of RAM, but people may hit memory issues with this as well. And though outside of the scope of this presentation to some extent, although if we have time we could do it, we could like natively run OpenDaylight on your laptop itself if we had to remove some of the requirements on that VM as well. The only requirement there would be you'd need Java on your laptop as well. The JDK, right?
JRE is fine.
JRE, yeah. Okay. So what I'm going to do now is I'm going to start talking through the OpenStack configuration on this as well. So while people are continuing to bring up their controllers, and we'll go through this slowly, and we can always back up to it as well when people get there. So in the same directory, you'll notice that there's a DevStack directory. So that's where the OpenStack DevStack project is checked out in here. And we have it set up, so we have the version that supports OpenDaylight. It's not upstream yet, it's under review at this point to go into the Icehouse release of OpenStack. But it has the version checked out that has support for that, and same with the Neutron ML2 mechanism driver as well. So if we go, the other thing is you'll notice there's 2 local .conf files, there's a compute one and a control node one there. So those, it's pretty obvious what those are, right? One of those is set up for your compute node, and one is for your control node. The compute node one will only run Nova Compute and the VNC proxy. The control node one will run all of the OpenStack control software. So if we go into the DevStack directory, you can actually copy the local.conf. I'm not going to do that because this is actually set up, but you can copy it, the control one over into this directory as just local.conf, C-O-N-F. And inside this, I'll just quickly walk through this. I mean, how many people have used DevStack before at all to pull an OpenStack image? So there's a handful of people out here as well. So, I mean, this marginally probably looks esoteric to some people as well. So I'll just kind of highlight some things in here at this point. Specifically at the top, this has undergone some slight changes. This used to be a local RC file, but the upstream folks have changed this so it's a local.conf, which makes it more flexible because it allows configuration of multiple files in the OpenStack setup as well. So if you look at the top, the key things here are we have offline equals true uncommented, which means that this assumes that it's offline. It's not going to try to pull any new code down or anything like that. And we have reclone equals yes commented out. That'll also signify it's not going to do any sort of git pull into your OpenStack directories as well. The other thing that's worth looking at here is these are the services that we're specifically enabling and disabling. I should note that we're disabling RabbitMQ because on Fedora, Cupid is the messaging daemon that's used instead. So some things that you may have to change on this as well, and I think that this is in the example file. The host IP. So this is the IP address, typically of the ETH1 interface on your host, the host-only interface that you want. So that's the IP address you're going to want to put for this host IP here as well. So if we look, I'm just going to stop this. So typically, like in my configuration, you can see right here the IP address. That's on ETH1, so that's typically the IP address that you'd want to use as well. Like I said, on the host-only interface. And as Madhu had mentioned, stay away from the NAT interfaces on VirtualBox for issues. So some other things worth noting here are, let's see, you'll want to change this VNC proxy client address as well to the same IP address that's used for the host IP address. This host name, this should be set up correctly. The service host is also the same IP address that's on ETH1 as well. And I think that the only other thing to change is at the bottom under this ML2 ODL section near the bottom. Again, this IP address, you'll want this to be the same as ETH1. So the example configuration file that's there should have these sections set up so that it's obvious you have to change them. I think that was the case, right? Okay. So we can walk through this as well because I know some folks are still working on bringing up the controller as well. So maybe while we're doing that, I'll go ahead and fire up my control node DevStack right now. So once you have that file set up correctly and everything, then it's as easy as being in the DevStack directory and just running stack.sh, which will likely take somewhere between a minute to 1 to 2 to 3 minutes. And that'll go ahead and fire up all of the OpenStack control services on this as well. So for folks who have never run DevStack before, on the Neutron side, it's going to create 2 networks by default. It's going to create a public network and a private network. The private network is for the tenants, and the public one assumes that that's bridged to a physical interface somewhere to get out, and that's where your floating IP addresses would be assigned. So that's what this configuration will do when it's done. So let's see. Now a show of hands. How many people have the controller up now? More people?
Yeah.
Are there a few more? Yeah, there's a few more.
Hey, Kyle,
Yes.
there's one person here having problem with VMware Fusion.
Okay.
So what is the problem?
It says import failed because
Does it give you the option to retry? Does it say? Yes. Oh, yeah, click the retry. That's a good point, actually. With VMware Fusion, it may fail the OVA import. Oh, it worked? Yeah. It'll say something about incompatibility, but it'll give you the option to retry. If you click retry, then it'll work out okay. Okay, so this is moving along pretty fast.
There's one more thing, right? Give enough time between starting OpenDaylight controller and the OpenStack controller. Now, if you do it so quickly, right, we have some issues with the timing, right? So,
Oh yeah, right. And typically, right, we'll get the OpenDaylight controller up first, and then we'll.
yeah, start it first, wait for a few minutes, and then
Yeah.
start the audio.
Yeah, that's a good point. So this is actually almost done running at this point.
Okay. Can you do an exercise into it?
Ah, yes. Question?
Do I have config on this one?
Exactly. Yep. And I can walk you here. Let me log back in another window, and I can show you.
ODL. Right. Yes, fine. Go on. It's
I can walk you through all the different places as well.
ODL at.
Although if you copied the local.conf.control from the home directory of the ODL user, I think it should be highlighted in there, right, where you need to change it with.
There's a tag saying
Yeah.
IP address of the controller IP address.
Yeah.
Whatever. Yeah.
I'll show you that actually right now. Oh yeah, this one doesn't. Yeah, this is a slightly earlier version of the image, but it doesn't have that change. That's the yeah.
Yeah, that's fine.
Yeah.
It'll be evident if you open the local conf.control, you'll see an ugly tag saying IP address of the
Yes.
OpenStack controller or whatever.
Oops, let's see.
It's in the root,
Yep. If you just log in as ODL, it'll be right
in the home, right?
in the home directory of the ODL user. Correct. And then you'll just want to copy that into the DevStack directory. You'll want to copy it just as local.conf without the .control extension.
Can you do another SSH? Open another SSH.
Okay, we'll pop back over here. So this is still running. Actually, it should be complete here in just a second as well.
No,
Yes.
yeah, just
Okay.
go into the DevStack folder.
Ah. So you'll if you look at your ETH1 interface,
Right.
that would be the one that you'd want to use for that.
Search for this one.
Are you using VirtualBox or Fusion or?
That's it.
Okay. Did you?
Yes. Whichever you are.
Okay, this is still running over here.
Yeah, whichever address is your non. Yeah, that's fine. Use control for it. You also copy the computer. It becomes computer. It will be another VM.
I forgot to mention, once we get this running, we'll see whose laptop fan is the loudest for having all this running as VMs. So. Okay, there we go. So this one completed. When the DevStack is done running, you'll see stack.sh completed at the bottom after all of this information as well. So has anyone made it this far? No, one person. Okay, a couple people over there. Is anyone stuck with anything at this point? We can come by and help people out. Yes. You guys.
Congratulate them for making it work so far. To congratulate them for making it work so far.
Yeah, exactly. Congratulations to the two gentlemen who have actually made it this far, so as well. Nice work. So, okay. So now,
That's fine.
once you get it this far, actually, the next thing we can do here is, and I'll just walk through this here. I'll bring up a web browser, and we'll just go to the IP address.
Hey, just one.
Yes.
The controller, if you look at the console, there'll be a lot of exceptions. Just ignore it for now.
The OSGI console.
Yeah.
Yes. Okay, actually, that's a good point. I should
Yeah.
show that.
Yeah, just ignore it. Don't.
So once-
very much. And maybe you want to show the SS.
Yeah, yeah,
You want,
yeah.
you want
SS?
SS OBS DB, and do a DM
Of
on the
85?
142.
142.
Yeah. So if you look at it here, right, you should be able to see the.
Scroll up a little.
No.
Oh,
No, this is right there. Yeah, right there. The cursor right there.
Okay.
The binding aware broker, it should be available, required available, right? That
yeah,
means
that's
working.
critical, right?
That means working. Yeah.
Yeah.
So even though the exceptions, just ignore them. This is the most important one. SS OVS DB and DM on the.
Right. So again, we
Neutron.
did the SSOVSDB to see all of the bundles, right?
Yeah, and do a DM neutron, the 142. 142 is the neutron's number right here, right? You have to make sure everything's registered. If it's unregistered, that means it's screwed up.
Right. And then you're looking for the binding aware broker there.
Yeah.
Yep. So the other thing you can do is we could look at print nodes, right? And we could see the nodes that are registered, right?
Well,
Maybe not. Okay.
it's fine, but the guaranteed one is to make sure everything is registered there.
Okay.
It's not been registered.
Okay, so in the meantime, we went to the IP address that we had for ETH1 here as well. We got the Horizon GUI, so we'll log into that.
Running, what's the next thing?
You got the dev stack running?
No.
So this will be your OpenStack instances up and running in that Fedora VM as well.
Search into the machine.
It's going to be a little bit slow logging in the first time, but
Okay.
And
Oh, okay.
hey, Kyle, is it possible to upload the PPT somewhere so that folks can download and start use? Since we are going ahead, right?
Yeah.
There are a few guys who are lagging behind. They are going back to the how to start the stack.
actually, that's a good point. We could copy them to USB.
Should I do it
maybe?
now? I do it from there,
Yeah, yeah.
from your laptop.
Yeah.
Twitter is a good idea.
Yeah, we could do that actually. Hold on.
You want to copy to the OpenDaylight wiki? You can do that.
You want to do it? Yeah, yeah.
I don't have the. It's the same one?
Well, I think I emailed them to you, right?
Same one?
Yeah, yeah. It's pretty much the same one. Yeah, there wasn't much change. Yeah. You want to do that? Okay. Okay. So this is the so we're logged into the Horizon GUI here. The other thing I wanted to mention was in another tab. I'll bring up the OpenDaylight GUI as well. This is actually Icehouse. Yeah, so because the reason for that is we're working to get this ML2 mechanism driver into Icehouse as well. So this will all be Icehouse and likely Icehouse from last week. So everyone will be running effectively the tip of the trunk at this point.
Why do you need ML2 if OpenDaylight itself can do multiple plugins? Just a pass-through plugin.
That's actually a good question, right? So the question was, why do we need ML2 with OpenDaylight? And it is just a pass-through plugin as well. The thing is, one of the things, and I actually, maybe a plug for my talk, I gave a talk on ML2 with Bob Kakura from Red Hat at Hong Kong. So one of the things that ML2 does is it removes the need for the plugin writer to deal with things like segmentation management, database management, and all these other things. The ML2 mechanism driver for OpenDaylight is only about 250 lines of code, actually. If we were to do that as our own plugin, that would be probably 4 to 5 times as big because we'd have to duplicate all of the database code and all of that. So while conceptually you might think, well, why do we need that? It actually ends up making a lot of sense from a code point of view and everything like that. Yes, yeah. Now wait a sec, why did this not, sorry, wrong. Mental note, always make sure you use the right IP address. There we go, look at that. Okay, so we can log in using admin and admin here as well. Now this, I can't quite, hey Madhu, do you know how? Yeah. Do you know this particular problem here? The GUI can't, I think, how do I, without,
Do on Zoom? Yeah.
how do I do that with just this? Oh, there we go. Whoops. There it is, got it.
Yeah.
Figured it out, okay. So,
The reason it's not connected is we have LTP issues, right?
yeah.
That's actually we're seeing the LTP is not decoded properly, 1.3. So you won't see the connections there, but trust me, there's a connection.
Oh, yeah. Yeah, so this is the OpenDaylight GUI. If any, admin and admin, yes. If anyone has questions on these particular things, I'll let Madhu handle the answer to those, or Brent, wherever. Okay, so now what we'll do is, we've got the OpenDaylight controller up. We've also got the control node for OpenStack up. Those are actually talking. So actually, if we look, so one thing we'll do before we bring up the second compute node is, let me show you this as well. So we'll go back to the host that we're on. We'll take a look at the OVS configuration now. We're using, let me just move this up to the top so it's easier to see. So we're doing sudo OVS vs kettle show. So we'll take a look at that. So what you can see now is, I think that BR ton is actually from a previous run. I should actually get rid of that. So ignore that for now. The BR int is what's important here. And you can see on the BR int, it's connected through that controller line right there. It's connected over to OpenDaylight. I should also make mention that the manager is connected as well. This is the OVS DB connection, which is connected up to OpenDaylight as well. On the BR int here, specifically, you can see a tap interface here. This tap interface is for the DHCP port that's created by Neutron when it's creating the private network as well. And then you can also see here, actually, this must be from a previous run because I haven't booted this yet. This is kind of confusing. Well, this should show up once I boot the other node. Okay, that's mildly confusing and I apologize for that. Okay, so let me boot up the second compute node now. Okay. Oh, what's the link here? I can share it on the screen? Yeah. I'll bring it up in my browser here. How about? I could just, what's the link?
wiki.openDaylight.org/images/3/32.
Oh, what if I just go here? Oh,
Yeah.
images
/3/32/ capital OpenStack _ODL_OVSDB.ppt. Yeah.
Like that? That should be the link. So if people want to download the slides locally, which has a lot of the information that we've covered, maybe that's,
We enter it once to make sure.
yeah, we'll just make sure that this actually starts pulling it down.
HTTPS.
Oh, is that what it is?
Yeah. Secure, man.
Oops.
Yeah.
Wiki images 332. PPTX or just PPT? Oh, PPT, huh.
Can stop it and retype it.
Yeah.
It works? It works.
Someone got it? Okay.
Get it
Yeah,
again.
yeah, yeah. Oh, someone was able to get it?
Yeah.
Okay.
We'll try it again if you want. I'm just going to see it. wiki.openDaylight.org. So images /
332. It's like ODL, OVSDB?
ODL_OVSDB.
Weird. Okay, it's not working for me,
But
but
that's the
that's the URL. I'm glad it's working for other people, though. Okay, how many people now have the controller up, at least? Does anyone else have a good number of people? A few? Okay. Anyone else have the control node OpenStack infrastructure up as well? Oh, a few other people. Okay. Okay, who cheated and went ahead and has the compute node up? No one? Okay, just checking. Okay, so I booted this. So I booted a second VM with this, and the way you can do this is you can clone this. I think, right, Madhu? That's probably the easiest way is to clone the first one, and then boot it up. It'll get a different IP address for ETH1, and then you can just. We'll walk through that as well, how to configure that. So what I'll do, I'm just going to log in here to verify what IP address I have here.
Root. The access denied.
Where? Oh, I can't.
Yes,
Okay, 34. That's what I was thinking. Yeah.
I see some rabbit configuration there.
What?
Rabbit.
Shouldn't be, right? It's commented out, disabled, right?
I saw rabbit in errors here.
So for password, I just enter all
Okay, hold on.
all the way.
Yeah, I mean, can you, if you don't mind, shall I?
I will run this again.
I'm going to log in here. So one thing that I'm going to do is I'm actually going to
Run this again.
redo this live in front of all of you. One thing I didn't do was clean up the OVS bridges in this from when we were setting all this up the other day. So I'm going to make sure that this is all cleaned up. I'm going to make sure this tunnel is deleted. Okay. So I'm just going to restart this stack as well. Let's see what's over here. Okay, nothing's connected. Okay. So I'll let this run in the background. Okay, so now. Okay, now I'm logged into my second compute node over here. So since you cloned this, it's going to be exactly the same. This is going to have OpenDaylight as well as DevStack on it. But you don't want to run OpenDaylight on this. This you just want to run the compute node on. So we'll go into the DevStack directory. You would want to copy the, I'll take a look at this here, local.conf.compute. So this is the one you'd want to copy into there. If we look at what this is,
Everywhere.
this one will be subtly different because you'll need the IP address for both your control node, ETH1, as well as the compute node, ETH1. So this should be set up with the host name of this VM. I think we just defaulted it to Fedora ODL2.
Yeah.
The host IP will be here. This is the compute host's IP address. So in this case, it's 134 for mine. Yours will be different depending upon whatever your private network is and what IP addresses were given out by either VirtualBox or Workstation or Fusion. The service host right here, service host name is going to be one there. The service host IP is your control node's IP again, not the compute node. So make sure that that's set up correctly as well. The VNC proxy client address will be the local compute node's proxy client address. And then the only other thing is you can change the ML2 configuration down here to match the control node's IP address as well. Okay, so I restacked over here, so we'll let that. I don't have to wait for that to finish actually. So now on the compute node, I'm going to go ahead and stack this. The compute node one will actually finish in about 20 seconds because it's really only starting up Nova Compute. So this one will go really fast actually. So again, if anyone's having trouble or has questions, raise your hand and we'll have people come by and help you out, bringing up either the OpenDaylight stuff or the OpenStack stuff as well. Uh-oh, failed. Oh, look at that! We can debug an actual failure here. Let's see. So it looks like in this case, my oh, did I actually?
Should be the IP address again.
No. I think this actually crashed OVS vSwitch-D. Okay.
Sorry?
On VMware, how do you clone?
It should be right click and clone. VMware, stupid VMware. I don't even know. I use one. I just,
And the thing is, when
Okay, so that cleaned it up. Let me restack.
so I don't even actually have the VMDK anymore just to from the spreadsheet.
you can export it as VMware.
It should have been because it's the same image as the first one.
Re-import this appliance.
Yeah, that's what I was trying to do, but then unfortunately when it's imported the first time,
So I guess I should note as well that these images are using Fedora 20, and as a result, they're also using Open vSwitch 2.0, which is one of the more recent versions of Open vSwitch as well. So, okay, that time it worked. So now, okay, it's connected as well. This one is connected as well. Okay, yeah, this makes more this is actually better now. So this is on the control node again. You can see that brint and brex are created here.
You need to clone the VM.
And then on the compute node,
Just re-import it again.
I don't see, oh, it's not created yet. Okay, let's go back over to the GUI here as well.
With the local dot
So now,
conf dot compute and then do the same thing.
now on the OpenStack GUI, we should see, once this loads here, oh. Where's Madhu, are you here?
Yeah, I'm here.
So as far as the brint on the hosts, we create that, we don't create that right away by default. OpenDaylight does. Once it gets connected, it creates it when we first do an operation down there, right?
Okay, brint, it's automatically created by the dev stack when it comes up. But if it fails, the OpenDaylight creates it. So we create it if it is missing already. So by default, when the dev stack connects to the controller, when the node connects to the OpenDaylight controller,
Yeah.
after that, it should be there. If not, there's an issue, there's a bug.
Uh-oh.
Mostly the bug is the OF 1.3 and it's not, Open 1.3 is not coming up or things like that. Either the OSDB is not fully up. You know, the one we discussed, SS OSDB and the unregistered one, that should be the most likely issue.
So maybe we have this issue. So in my case, I didn't get it.
Oh, you also, yeah. I mean,
What's going on?
do you get an OJ? Yeah.
No, I see them both connected.
Oh, it is in dev stack, right? It's in the compute.
Yeah, yeah.
Oh, can I do print notes again if you don't mind? Well, yeah, it's fine. Seems okay. So 134 is the new thing, right? 134 is a compute node.
Yes, yes. So I don't know why it didn't. I could try.
Can I do one thing? Can you do a Dell manager and do it manager again? OVS, VSCTL Dell manager.
Yeah. We'll do that.
Or the really unstack, that'll work. Set manager.
Ah, that's right.
That's the reason. Do a TCP there.
Oh.
TCP caller. But that's not the issue right now, but let's see.
Connected. Okay. This error, right?
Stats. It's a stats issue. It's not OSDB stuff. Okay, hold on. I'll be right there, man. Right there.
Yeah.
Underscore ODL underscore OSDB.ppt. No, cap small.
It's interesting.
Underscore OSDB.ppt. OSDB.ppt. Yeah.
What is that?
Yeah. Welcome back.
Okay, that's. Well, it's a real demo, right? So that's always.
This is the reality, man.
Yeah, exactly. Yeah.
No, this is the exception in the. This is not wrong. This is in total package, right?
So maybe it's up here
Yeah,
somewhere.
yeah, scroll up. Keep going. Up. Oh my God. It's all not.
I know. Maybe we should restart, delete the connection, restart it. Maybe it'll trigger a message.
No, if you do unstack again,
Sure.
can do do unstack.
Yeah, and then we'll restack.
Do a really unstack also. It's okay.
Oh,
Because they have to do the dill manager and all.
that should have done that. Okay, let's see over here. Let's see what we get over here.
You're supposed to get it. You do a print notes again. It's
gone.
only one OBS
Yep.
is gone, right?
Yeah, that's good.
It's supposed to come back.
Yep, yep. Wait, what happened? Oh, it's still going. Oh, there's that our error? Oh, session for the cookies invalid. Session for the cookie session. Print notes, huh?
Two OBS, yeah.
Yeah.
Can you go back there?
Restart?
I'm thinking.
Yeah, that's what I'm thinking. You know, restart controller. You can restack everything.
Only the compute node, right?
Yeah, it's only like 950.
Because controller is working.
Wait, but if I kill the controller, I have to redo the.
Don't kill the controller. Controller is not good.
Oh, but I've done. Okay. Oh, you mean you want me to completely wipe this out?
Yeah, how about this?
Yeah. So we're working through some technical difficulties with the demo right now.
It could be using this.
Yeah. Okay. Yeah. Yeah. Okay. Oh. Okay. Local RC. Yeah. Okay, so that's actually a good point. A gentleman at the front ran into an issue where if you killed, maybe you hit Control C or something, or it exactly. If you end up with a local RC that's halfway generated and is maybe empty, and you run stack.sh, you'll get a message saying, I found both local RC and local.conf. So you can actually unstack, delete the local RC, and then you rerun it, and it should be good. Yeah. Yeah. I don't know if I have it really. No, I don't. But we could delete the. Yeah. There it is.
It's fine.
Yes.
This is our controller, right?
Yeah. Yeah. Those are
Right. So what we can do all this, I'm just thinking.
Is there a way to delete that connection from?
You see this empty side is failing here, right?
Yes. Yes.
Empty side is failing.
Yes.
This attachment is right. I'm confused actually. So, hold on. There's some live debugging going on here.
For some what?
I'm enabling
Yeah.
debugs.
Oh, got it. For those curious, we're now live debugging this problem. Thanks, Madhu.
It's fine.
Looks good.
I don't know what.
Is this where we finger point at Ryan?
Not right. It's not right.
I'm just teasing. I'm just gonna make him feel like he's involved since his name is on the slide.
Everything seems okay. So this is what I should expect.
Yeah. So it should be going, right?
Yeah. What?
Yeah. What time is it? Does it go till 10:02? It's 2 hours. Yeah. So I think we have. Yeah.
133.
Actually, that's a good point that Thomas just brought up. So this session's actually 2 hours. So if everyone can hang with us. We still have another hour to go. Yeah. So we'll get there. That's why we'll take a little second to look at this problem before redoing things. It'll only take 5 minutes. Kill everything, restart. Yeah. Maybe just. Yeah, that's easiest. We don't want to. I mean, otherwise. Yeah. Let's do it. Okay, so I'm just going to due to the unknown nature of this particular issue, we're going to restart real quick. Yeah, I'm just going to restart my controller and my OpenStack control infrastructure and everything here.
Computer configuration, just to make sure.
What do you mean?
Compute the vim local.conf. Just to be
Sure.
Yeah, sure.
34.
Host IP, proxy client.
33, yep. And that's it. And
So
Yeah.
let's service nodes view 133 out as well. Go.
yeah.
133.
Yep,
Yeah, that's fine.
that looks good, yeah. Okay, let's just take a look at this here. Yep, that cleaned up. Okay, so we'll kill the controller. So wait a sec, so 1.3. I know, that's, I don't, OF dot version, 1.3, so yeah. But it was for the first one. But yeah, it wasn't even calling it at all, was it?
Nothing's being done. Because typically what happens is the node comes up, immediately the information goes to Neutron, Neutron just starts creating the bridges and everything.
Yeah. Yeah, it should right away, exactly. And it did on the control node. Everything was. Oh, success? No. Okay, so I'm just restarting my OpenDaylight controller here.
Say the code right away.
You want, yeah, pull it out. Yeah. Sit right up the end. There's a seat on the end. So, did anyone get all three things up? The OpenDaylight controller, the control node for OpenStack, and the compute node? No? Okay, let's wait till this. Okay. There we go. Okay. So this is up now. Let's see. Broker. Got it. Okay, so that's good. Okay. Now I'm going to restack over here. Okay, so I'm restacking my control node at this point. Oh, didn't I do that? Should be okay. Couple minutes. I think so, at least in theory, right? Yeah. Restack my compute node at the same time as the control node here as well. Much better, Madhu. Yeah, worked. What? You knew it was going to happen during a demo, though, right? It never happened before. Yeah. Okay. Okay, so after the restarting everything, now on the compute node we have the brint created. So Vinay, you were right about, that's going to be created after the connection is set up between OpenDaylight and Neutron. Yeah. Let's wait for my control node to finish the restack here. Okay, this is almost complete. Okay, there we go. I think we're back. Let's take a look here. Yes. That looks better. Okay. Yeah, okay, so I'm not, Madhu and I aren't quite sure what was happening there. We've not seen that issue before, and so, but we're back now to where we were. Okay. Here, you want to talk about that since you did that?
Yeah, so we also see the GRE tunnel established between the two compute node and controller node.
And it's worth noting that those are on BRINT, separate tables.
They are on BRINT. You
On
can
the
do-
single bridge.
The OF code.
Yeah. Wait, is that it? No.
No, not it. Once you create the entries, you start seeing things.
Oh, right, okay. Okay, so now I'm going to jump back over here. I'm going to log out of this one, refresh this, which will force me to log in back in since I restarted everything. Okay, so we have all of these bridges here. There we go. Okay. Now, we'll log back in over here on the OpenStack side. Just a sec. Yes. No, the tunnel was created, so Madhu, we create the tunnel ports are created when the multiple nodes come up, right? Right?
Yeah. So for 1.3, since we have just one tunnel between the nodes, we create just after the node is created, really. Because the reason is because the DHCP, in this example, the DHCP is actually on the controller node. So anyways, any compute will need access to the controller, right? So we create it as soon as we get the node up. But in OpenFlow 1.0, since the tunnel resources are very critical, we create only when there's a presence of a given tenant on a given compute node. So 1.3, it's because anyways it's going to be only one tunnel per pair. Per pair. So across all tenants. So it's okay to create it.
Yeah.
Right. Only once, that's it.
Right. So one thing I'd like to highlight here is once you log into the Horizon GUI here, as admin, you can see, if you click on the hypervisor tab, you can see both of the hypervisors show up, and this is because we're running Nova Compute on both the control node as well as the second compute node. One other interesting thing that kind of was alluded to in the discussion that Madhu was just having here was the fact that for the hydrogen release, we're actually still making use of, on the Neutron side, of the DHCP agent and the L3 agent on the Neutron side. So those services are still running, so we're still doing all the routing through Linux network namespaces as well on network nodes on the Neutron side. That's one of the things going forward that like a future item that we'd like to do on the OpenDaylight side is to handle certainly the L3 stuff, at least on,
Yeah, so
on OpenDaylight.
So the way we are done in this release is that once we set up the flows, open flow rules on the compute and control, the controller never sees any packets at all. since OpenStack has all the information about the VMs and DHCP addresses, we proactively program all the flows needed, and controller is completely isolated after that, right? The OpenDaylight controller. Well, we flood the R packets, we flood the DHCP, things go to a place where it has to go, get resolved. So things work in a demo setup, but it doesn't scale. We know that. So our idea for the next Helium release is to make sure we go a step further and involve more controller pieces into it, if there's a need, right? So we want to keep it flexible because we spoke to a few customers. Each one of them have different scalability issues. If you have if everything goes to a service node, then the service node doesn't scale. If everything goes to one network node, the network node doesn't scale, right? So we are getting conflicting requirements. So we kept it easy for now for the Hydrogen release. We flood, and get things resolved. And we also saw an upstream commit from in Novius DB where the local Open vSwitch resolves the R preservation as well, right? So we have to go towards that area where keep it local to an edge, keep everything resolved on the local node rather than getting distributed to multiple devices or a single service node. So our objective is to go distribute the control to individual Open vSwitches and make it proactive as much as possible. Yeah.
Yeah, definitely.
And OpenStack is one of the best examples for this proactive mode because it has all the information that we need possibly, right? So,
Yeah.
sorry? Okay, topology alone, right? That's exception where we leak the LLDP packets up. So if you look at the rules, you'll see that there'll be a LLDP rule alone programmed there, right? So we filter out saying 0x88cc, all right? So those packets send it to the controller so that we can learn topology. But practically, we don't need the topology at all. It's mostly for the UI purposes and for the applications to use that. But OpenStack itself, we don't need the topology because it's end-to-end tunnel, right? So once you know which tunnel to take, who cares about the topology, right? It's just, right? It's one hop, put that way.
Yeah.
But it's good for the UI. If you want to see a good UI with
Yeah.
multiple tunnels, definitely yes. I mean, that's when we program the LLDP alone for punting it up.
Can you show the network topology here on the horizon on the OpenStack dashboard?
Sure. Sure.
And this is another question, right?
And this will look the same as if you're seeing anything else as well. So that's the admin view. Let me get in his demo here. And go to topology. So it's a pretty standard dev stack, public-private network with a router set up between the two. So, okay, so the next thing I was going to show was actually booting some VMs on this. So then we can take a look, like Madhu alluded to earlier, some of the flows that are set up on the Open vSwitch bridge and things like that as well. So let me quickly show this. This is in the slides that people have downloaded as well. So what we're going to do is we're going to pop over to the project tab, make sure you're logged in as demo. So that's what this arrow is showing. I was trying to highlight for people new to Horizon what you want to look for in this GUI, specifically for launching these VMs. You're going to want to make sure you go to the instances tab down here, and then there's this launch instance button over here. And then this may look like a lot, but it's really not. It's kind of a waterfall here. You'll start with giving it a name. You can leave the default flavor that is selected. An instant count, you can give it 2. It will launch 2. You could launch 1, launch another one later. You want to make sure you boot from image. The Ceros image will be what you select, and then you'll pop to this network tab and make sure you select that. So let me show you that live as well. So we're in the demo. We're going to go down to instances here. We're going to go up here to launch instance. We'll just call this a demo. We'll leave this at nano. We'll set 2 for the instance count. We'll boot from image here. We'll do Ceros. We'll pop over here to networking and select the private network because we're logged in as the demo tenant at this point. And then we'll click launch. Okay, this will take a second to reload here. Didn't I? Yeah, there it is. It's still. to do is actually pop over to the admin tab here. So we got the launch 2 instances. What I wanted to show here was, if you go over to the admin tab, since we're logged in as admin, we can see where, which host the VMs ended up being launched on. This is being a little bit slow, but you can see once we get over to this admin tab and we go to the instances here, you can see that it launched 1 on each of the hosts. So this VM got launched here and on the ODL1, and this one got launched on ODL2. So now if we go back over here, now if we look at, where is that? That should have, wait a sec. First, let's do this. Let's log in here. So we'll click on the instance name, and that'll give us this instance overview. For those who have not seen Horizon, this just kind of dumps everything that you set it up for, tells you the flavor, all that sort of stuff. We'll go over to the console here. Okay, so we'll scroll up. It's kind of a bizarre thing with this no VNC proxy. You have to kind of click in this gray window and then click down here. And it actually, you can actually see it tells you the login here. Ceros, because this is the Ceros cloud image. And done by a Chicago sports fan, right? So Cubs win is the password with a smiley face at the end. Okay, so now we should be able to see in here if we do an IF config. So this particular image got the IP address 10.0.0.3 from the DHCP server as well. So from here, if we go back, hold on, if we go back here, this image got IP address 10.0.0.2. So actually, let's log into this one as well. Let me scroll this up a bit. There we go. So you can see this one got 10.0.0.2 like it said. So we should be able to ping across to the other guy, which we can. So now, one thing that's worth doing, if we look at, so that VM is actually running on ODL2. So if we're on the control node here, one thing we could actually do is we could actually look at the traffic, at the ping traffic, and this is of course going to pop up my handy VMware. Just a sec. There we go. So you can actually see the encrypted or the tunneled ping traffic between the tenant networks going across between the 2 hosts here as well. Mildly interesting for those of you who like ping demos done over a GRE overlay, but still. We should be able to. Wait a sec. Let's see. We should also. Shoot. Isn't that it? No, I think I'm doing this command wrong. Madhu, what's the command to look at the flows again? That should be it? No, I'm doing something wrong, right? Yeah. Okay. Version negotiation. What? Sorry. Is it? That was. Oh, dash O. That's what the problem was. Yeah. I always get that messed up. Yeah, dash O. There you go. Okay.
A lot of flows, guys.
A lot of yeah.
You want me to talk over?
Yeah. Go for it. Yeah.
All right. So yeah, there are a lot of flows.
Do you want to point to the screen or no?
I'll highlight it here. Right. So we have this controller and these are the compute here. Let's do the same command.
Yeah, that's the compute. Yep.
Dump flows.
So what we're going to show here is all of the flows that are set up on the multiple tables on the BR int, because we're using OpenFlow 1.3.
Yeah. So if you look at it here, right, of course the controller node will have more flows because it has multiple guys talking to each other. Since we use OpenFlow 1.3, we use only one bridge, the BR int, not BR tunnel. And since there's only one bridge, we don't use normal forwarding at all anywhere. So every flow has been hand-coded and programmed. So for example, if you have 10 VMs in a given compute node, you will see at least 10 flows for doing the unicast forwarding for between them. You'll see them in table 20. So you see there are 3 tables here. Maybe I'll filter it based on tables. It's easy to understand. There's a lot of flows here. Sorry, guys. There you go, right? So table 0 is the default table where all traffic just comes in Open 1.3. In 1.3, the way the multiple table works is traffic comes to table 0, and then it can get routed or get classified and go to any other table, but it cannot come back, right? We don't want to cause a loop there. So what we have done is we are using 3 tables, and table 0, table 10, and table 20. Table 0 is the default incoming table. It classifies, and then sends to the appropriate table. I mean, the table space is a really bigger space, so we didn't use table 1 and 2 because since we cannot come back, we gave some enough space, at least 10 table spaces, in order we want to patch the things up during the release, right? So we have 0, 10, and 20. 10 does a classification, as the gentleman pointed out here. Traffic coming in, so if you look at, let's take an example here. The first one indicates that any traffic coming in with tunnel ID 2 and in port 2, meaning this is traffic is coming in from the tunnel, right?
Sure.
Yeah. I mean, sudo vs vsctl, dpctl. Sure. There you go. But guys, one more thing, right? The dpctl's port number is not the open flow number. Okay, you have to be very careful here because it's easy to get. No, the open flow numbers are different, right? So if you want to know the open flow number, the best command to use is sudo obvious
Translate, I think.
db client dump, right? If you do this, right, these numbers are guaranteed to be open flow numbers. So if you go up to the interfaces, guys, one more thing, right? The DevStack OpenStack integration is not a simple one. We all know that. So Brent is one of the best bloggers I know of, and I'm glad he's part of this project, right? So we are going to blog it out, really, and after this release, we're going to blog, we're going to record videos, and we're going to be doing all those. So hold on till then, because we are coding till the last minute, right? So documentation comes at the end. So if you want to know the OpenFlow number, dump the OSDB client, right? And then interface table has this thing OpenFlow port right there. No, it's in general, it's open vSwitch, right? I don't know the reason for it, frankly, right? But the OpenFlow number doesn't match or need not match the DPCTL number. Need not.
Right, the data path ports of their own
Yeah.
IDs
As you can
versus
see
the
here,
OpenFlow
right?
ports and vSwitchD.
The OF port number is 2 here, which is the GRE tunnel, right? But if you look at DPCTL, it's be different. Okay? So just please realize it's not the same. Okay? Yeah, so the 2 we saw is the tunnel ID, and the same thing you can see it in this command here, right? Where traffic is coming with tunnel ID, I mean import 2 and tunnel ID 2, meaning this is the GRE tunnels GRE key that we use for the demo, right? So GRE key, we are saying, okay, traffic coming in from this tunnel, don't send it to 10, send it to 20, table 20, right here, right? So this is one classification for a given VM, given tenant goes there. And as you can keep seeing here, traffic coming in from tunnel 1, right? Send it to, again, table 20. So what we're doing is we are taking traffic from tunnel, sending it to table 20, meaning table 10 is going to be used for local forwarding. Table 20 is for now remote coming out and going out, right? And this one, if you look at the third entry here, you can see traffic coming in port 1 and DL source. So what we're doing here is, it's a local VM on a given node. Import 1 is the local tap interface, which is a VM is being created. And we are filtering for a given source address, so we don't want to receive multiple source MACs on a given same tap interface, one port to one MAC. And the action is to set field. So this is where we classify. We say, you know what, the port 1 of this node belongs to the tenant 1, right? So we are using the OpenFlow 1.3's native OXM headers. There's no proprietary NXM headers here, right? Which is good because this is one. We saw multiple solutions out there This is the only solution that we have, which is purely open. This OpenFlow 1.3 with no extensions, OSDB assets, no extensions, right? It's purely out there. If you implement OpenFlow 1.3 properly, right, you'll get the results exactly you expect. So the action is to set field and go to table 10, and so on and so forth. You can see all the flows here, and you can do the table 10. So table 10, of course, you'll see the local forwarding and the packets coming in from the incoming port towards the external network to go inside the tunnel. So if you look at here, you'll see most of the flows with output port is 2. For example, if you look at this case here, we are filtering on flooding. This is the flooding interface. If you look at it, we don't do 0xFF, because any flood, we want to catch any flood, including the DHCP or whatever, right? It's not necessarily FFFF. It could be anything starting with 0.1 in the MAC. 1.3 supports MAC masking as well, right? So we use it effectively. So we do the real destination with 0.1 and mask with 0.1. So all multicast, broadcast, MACs are covered here, and all of them are sent to the tunnel, right? So we send it out. I was explaining about the same point where ARP, DHCP, everything is being covered by this flow, exactly this flow. And then we try it out. When we fix the helium part, we might change stuffs here based on the requirements. I will give configuration requirement where eBay might want to do it differently. You guys can tweak it to make it work. So this is if you look at the configurations here, this is the most basic OpenFlow rules to make DevStack work or OpenStack work out of the box, barring all the bugs, if not fixing all the issues, right? This is table 10, and table 20 is for the flows coming from the tunnel going into the network. And you can see the packet flows and everything too. If you want to trace the flow, you can trace the flow appropriately. From if you do a ping, you can start seeing the flows hitting it and everything. And exactly the same on compute node and control node. Doesn't matter. It's going to be the exact same explanation for a compute node. That's it. Any questions, guys, on the flows itself? So we typically use 2 commands, the OpenFlow rules and the OSDB rule, right? So typically things will work as is. When there's a bug, that's when we start debugging things. We go deeper inside to dpctl, into OSDB dumps, and going further deep inside. Yeah? Right. DevStack and OpenStack is a great example for proactive, because I can show you quickly one sample, then you understand why it is so simple here. I'll do a OSDB client dump, right? See, the OSDB is just a simple protocol, right? But the reason it is much beyond a protocol is that it enables a lot of things like the one I want to explain right now. The libvirt and the Nova's piece of it on the DevStack populates the OSDB's the port interface. So if you look at the OSDB here, I'm going to go inside the interface table. Okay, what the controller what it looks for is table interface table. Interface table right here. There you go. This is the one, right? So if you look at this interface, this is the most important information that you will look for in an OSDB Neutron plugin. That is called, it is part of the external ID column, as you can see here on the interface table. So for nerds who wants to look at the OSDB schema, you can see OpenVC schema has this table space as interface table with external IDs there. The external ID is populated by the Nova and libvirt. Libvirt does it, gets information from Nova, I guess, right, and then populates it there. And that information comes to the controller via the OSDB channel. Now, as you can see here, the attached MAC of a given tap interface is exposed on a given OSDB channel. So OSDB channel resolves to a given node, compute node, and we know exactly the location of a VM, right? So if you want to know a location of a VM, right here, the attached MAC is right there, right? So attached MAC, whichever node, OSDB node gets it, that means it belongs to that particular compute node. And we resolve, if you go back again, if you scroll down this one, you can see the local IP configuration here. So based on local IP configuration, we know this compute node has this tunnel endpoint. With that information, we know exactly to reach a particular attached MAC, right, on a given tenant, use this tunnel destination IP because that resolves to a given node. The control knows everything. We program it source compute node. So what you do is we get it proactively, yes. Okay, that's the difference, right? As I explained to you guys, in the hydrogen release, we are doing everything proactive, right? Proactive meaning we learn it, we just populate it. And the population doesn't happen blindly. We populate based on the presence of the tenants. So I have, say, 100 compute nodes, right? And I have a new tenant coming up, and there are 2 VMs in 2 different nodes, and only these 2 nodes will get the proactive flows because there's no need for these guys in any other node because there's no tenant available there, right? So we try to do some intelligence there, but of course we can do conversation learning and so on and so forth, but it's coming later. For this release, it's pure proactive to kickstart the process of integration, really. And we saw it's not too much deviation. In fact, many solutions do the same, right? They don't wait for conversation learning or anything. Just program it proactively and be done with it.
This is done by the
OpenDaylight. So,
OpenStack is also a mechanism for L2 population,
Right. You're talking about the ML2 population mechanism driver, I suspect, right? Yeah, right. So yeah, so OpenStack has that. It can do that as well, and it will proactively do that.
oh,
So actually, that's okay. So I was going to segue into this, and this was actually a good segue, right? So with all of those mechanisms that you're specifically L2 population, or even the Open vSwitch plugin or the Linux Bridge plugin, all of those require an agent on the host. So they all have an agent. They all have RPC calls going back and forth between the Neutron server and the agents. So you can imagine the scalability concerns between that, right? So this approach removes that agent, and now we have the OpenDaylight, which is actually handling the connection to the host using OVSDB and OpenFlow as well. OpenDaylight is a Java application, so there's a lot of knowledge around scaling Java applications and that sort of thing. So we think this approach is a lot more scalable. And in fact, one thing that this allows is, with the current Neutron, either ML2, Open vSwitch mechanism driver, or the Open vSwitch plugin, if you were to load that up and actually try to, say you just set it up with 3 hosts, 2 compute hosts and 1 control node, you try to boot 50 VMs at the same time, you can't really do that actually with the Open vSwitch mechanism driver or the Open vSwitch plugin. It takes a long time, it may not even work. But with this environment, with OpenDaylight, you can boot 50 VMs simultaneously and they'll be up in a minute. It removes all that RPC mechanism, all of that latency and everything like that. So one thing is we're actually working with, I'm actually a Neutron core member as well, and so I've been working with the Neutron folks to try to see how we can make this OpenDaylight mechanism driver not the default, maybe eventually make it the default open source plugin for Neutron as well. In other words, we're trying to get it set up into the gates for Tempest tests and things like that. So, yes, question in the back.
yes. So the current OSDB Neutron doesn't support VLAN yet, right? We support only GRE and VXLAN, and yes, we can support both. Yeah, on the same compute nodes, we have one tenant can be in a GRE network, other tenant can be in a VXLAN network. Yes.
So now that brings up a good point, right? The OpenDaylight mechanism driver doesn't support VLAN, and what that means is if you're using ML2 and you create a tenant network that's type VLAN, it won't bind any VMs to the OpenDaylight mechanism driver. However, if you do need VLANs, you could run the Open vSwitch agent, the Linux Bridge, the Open vSwitch or Linux Bridge mechanism driver using VLANs and bind them there, right? I mean, if you wanted.
Any reason why VLANs was not?
There's no reason. Actually, it's a lack of time, really. So building a time to get I'm sure VLAN is the easiest one to go, but we couldn't do it. I mean, the OSDB couldn't do it, but OpenDAO, Ryan is here, right?
I was going to say, you guys, if this doesn't know how to get done now, if folks want it, it's a great way to contribute back.
Even better.
But to be honest, the VTN guys implemented the VLAN stuff, right? If you look at the VTN plugin, they have the VLAN stuff implemented. But Ryan is right. Somebody interested in VLAN contributed to this one. Please come contribute. We'll be happy to take that. Thanks, Ryan.
Yeah, right, exactly. So the other thing is, oh, a question, sorry, go ahead. Yeah.
How do you map the wave to a tenant? I didn't find that in your thing. And also I saw that you create a port on VRN, you create the tenant to a port, right? So if I have multiple tenants, do I create multiple ports on the VRN?
Great question. Go ahead.
Yeah. So BRN tap interface are all created by Libbird, right? So every VM that comes along needs a tap interface. The port is being created. That's by default, right? And let me go back and highlight this one, the mapping. That's if you look at the end-to-end picture of how the controller on Neutron works, it's a very simple logic actually. There's no complicated thing at all. And, I mean, the most complex thing is to really bring up the dev stack environment really. But after that, I was actually giving a hint yesterday's conference, this meeting, right? It took us less than 2 months to get everything working from 0 to where we are, including 1.0 and 1.3. That's because all the information, dev stack is one of the most valuable, rich information it already has, OpenStack, right? So to showcase the mapping, the question that you asked, again, this is the most important critical piece of information that we have, right? The attached MAC is the MAC of the given VM. The interface ID here, this is the UUID of the port that is created by the Neutron ports. Hey, do you have the slide? The big slide?
No, not easily. Something happened, it crashed, sorry.
All right.
I can
There's-
get it while you talk about it.
Yeah,
Talk
okay.
And I'll pull it up.
Right. So if you look at the overall architecture, OpenDaylight talks to the OpenStack talks to OpenDaylight via the Northbound APIs. The Northbound API, thanks to Ryan contributed the Northbound API for the OSDB Neutron. So OpenDaylight Neutron. That actually takes all the calls from the Neutron Northbound APIs. And on Southbound can be any of these modules working on it. So the Northbound OSDB and the OpenStack, the OpenDaylight's Neutron Northbound API gets all the information like the Neutron network, Neutron port, and Neutron subnet. There you go. This is the one.
This is going to mess with stuff, but go ahead. There you go.
There you go. This is the one, right? So this is the overall architecture. I know.
Weird. Okay, just get out of full screen then.
There you go. That's fine. So this is the overall architecture. I know this is a lot of information here, but it's kind of pretty simple if I dissect it further. It's all right. It's okay. So we have this Neutron with ML2 plugin right here. It talks to the OpenDaylight Neutron REST APIs through the REST API calls. And then we have multiple modules here. It could be OpenDAO, it could be OSDB, it can be VTN, it could be whoever it could be. Since the demo is on OSDB, I highlighted only the OSDB here. No foul here. And the OSDB Neutron application really talks to the ADSAL interface for OpenFlow 1.0 and MDSAL interface for 1.3, right? And OSDB is still an ADSAL interface, right? That's why we see a lot of things on the ADSAL side. So we use any information coming from the Open switch, including the attached MAC and whatever information, gets to the Southbound plugin, it goes to the Neutron application. Similarly, the Northbound APIs get the information here, right? So if you look at the assimilation of information, what happens is the Neutron gives the port UUIDs, the Neutron port information. The UUID that you see on the Neutron side matches, it's okay.
Oh. Yeah, this is that weird problem I told you about. There.
Yeah, okay, thanks. The port UUID that you see on the Neutron side will match the interface ID right here. I don't get my mouse right here, right? So the interface UUID ID here. So
Bring up Horizon and show them the port table, because that'll show them the Neutron network.
I can go even nerdier. You want to do that? Let's do a nerdier one. I like to be a nerdy one. All right. I can do a dumper default Neutron ports.
There it is. You want to point?
Yeah, I can do it.
Be our virtual laser
There you go, right? So if you look at the controller has all the information, of course, right?
Horizon's much prettier.
Right? Yeah, go on.
Yeah, so basically, we'll take the first line of the neutron port up there, if you guys can highlight it.
Oh, yeah, you want to highlight that up there? Yeah.
Basically, you've got the port, this is a dump of what you find.
Ryan, here.
This is a dump of what you find in the neutron, neutron interface for ports, but also inside of an InfiniSpan cache in the controller. Port UUID is assigned by Neutron. The Neutron network it's part of is the network UUID, so you could dump that to find out about it. We haven't given a name. I don't know why you guys didn't. Whether it's up or not is the admin state true. MAC address is the part we were talking about. What's the MAC address attached to it? And then what the IP address of it is.
You don't be here.
Oddly enough, you guys done something rather interesting with that. Yeah, the fixed IP. Oh, all right. We don't.
It don't be here. It's not
we
exciting.
don't dereference it.
Yeah.
This is actually in the spec. If you look in the Neutron spec, when you get to fixed IP, it's an actual structure. It points to a subnet, UUID, and gives you an address out of that CIDR block that you're actually using. So if we went and looked, we'd see if it's either 10002 or 10003. I don't remember which one it is.
Right.
And then last but not least, device. What device owns this port? In this case, we set it up for a router gateway. And then this one doesn't have a tenant because it's on a router, but if you drop down to the next one, you've got a tenant ID, and that's also set up by Neutron. Oh, actually, it comes to Neutron from Keystone. So that's how that gets plugged in.
So once you have the information from the northbound, and you saw the OSDB giving us from southbound, right? A given tap interface has a interface ID. We map with this port ID here. This is our UUID, right? Universally unique identifier. So looking at that port ID mapping, we know which tenant it belongs to. Once I know which tenant it belongs to, I can look at the network ID and go to the GRE key, and voila, we have all the information we need, and do the proactive forwarding. So
there's a one-to-one mapping between the ports that you create.
Yep. Yeah. So it's pretty simple if you ask me. If you look at the beauty of this OpenDaylight architecture, I like it because of the OSGI, the way it is done. So anybody can build a module. Like for example, Ryan built it on his own time. I built my own OSDB. We all put together and we didn't even interact really, right? He has these interfaces defined. All right, Ryan goes to sleep. I look at the interface. All right, I implement them, and that's it. It's like really a magic come true. In fact, Ryan wrote the northbound module. In fact, we never interacted when we integrated. Really, he was surprised. Why didn't you even talk to me? Because we don't have to, right? That's the beauty of OSGI, really. Yeah.
If you don't mind, could you just go back to how you correlate the port creation on the computer and the Neutron? You just go through that again one more time.
Yeah, sure. Yeah, I'll do the dance again. Right, we all know, right? This is the tap interface. It doesn't show much, right? What really shows a lot of information is the OSDB dump client, right? If you do OSDB dump, client dump, it shows all the information you need from an open vSwitch perspective. So the OSDB channel is a bidirectional JSON RPC. It's very critical because the controller, the OSDB plugin, keeps listening to what is happening on the OSDB switch, whether we program it or somebody else programs it. So that's the reason when the libvirt programs this interface table with this information of attached MAC, we keep listening to it and we get the information because we do the OSDB monitor. So we monitor and get the information. So the tap interface, which also has the OpenFlow port number, right? And it has the external ID column with attached MAC interface ID. We use this information. So if you look at we don't use the VM ID per se because we can get it from anywhere. It's not information. The attached MAC and interface ID are used. The interface ID is the port ID that you see on the Neutron port, right? So whatever you see in the Neutron port here, which you got from the northbound from the Neutron side, we map these two together. So once from an interface ID, we get to the port ID. From the port, you can go to the tenant and the network, right? Once you go to the network, we know whether it is GRE or VXLAN. Once the network is going to give us what is the key, GRE key or VXLAN key, right? So we use all segmentation IDs from there. it's like a chain. It's like a really linked chain. If you look at the OpenStack, all these Neutron network, Neutron subnet, Neutron ports, Neutron routers, and whatever, right? They're all like a chain, links of UIDs. So you can take one UID, you can traverse anywhere you want to, really, right? So all you need is the hint that you get from the OSDB's external ID column. So the OSDB Neutron application sitting on top keeps listening to all this important information. So if you look at the code, if you look at the Neutron code, you'll see that OSDB Neutron is an application, really. It makes use of the basic infrastructure that we already developed called the OSDB plugin and OSDB libraries. That's the two bundles which is running on the base controller. So the only difference on the virtualization edition is we added this application which listens to whatever the base thing gives, and we listen to only what we are interested in. We are not interested in statistics yet, so you'll see the code to remove all stats updates. We look only for this update, and then do the.
So what you're saying is that we will set up the whole full mesh of sharing accounts, whatever is needed for that particular tenant. So you also need to find out all the repeat hosts for that particular tenant.
But the key is there's only one tunnel between them, right? And we're doing the flows, right?
One tunnel per.
We're
one
not
tunnel
doing.
per node.
Yeah.
So that's how OS.
let me go to this
that's
next
how
thing.
ODSDB does it.
Right, yeah.
VTN does it different.
VDN has no tunnels, actually. They have VLAN stuff.
does it different as well.
Just wait, I'm going to go to that. Hold on.
One thing, apologies for jumping in here, and I'm gonna steal, and now I am going to steal the mic. One thing that I wanted to point out, just because you have the Neutron application and bundles in the controller, you don't need OpenStack on the top to actually configure this stuff. If you want to write your own REST client or just make straight REST requests, you can do that. When I do the OpenDove tutorial in a couple of hours down at the other end, I'm not going to be running OpenStack on top of it. I'm going to be doing raw REST requests in.
You're a smart guy. You're a very smart guy.
Into configure everything. No, I'm lazy.
You are smart. Hey, it's a very good point. Even though we call it a Neutron outbound API, the gentleman named Hugo from the Cloud Stack, he has already implemented Cloud Stack with this one. Meaning, he doesn't care whether it's called Neutron, because end of the day, it's a REST API, right? So he wrote a plugin on Cloud Stack. It calls the exact same APIs, and now we are glad to announce Cloud Stack also works with OpenDaylight.
And the best part is those actually are real Neutron APIs, so the Cloud Stack guys are using the Neutron APIs too.
One last question. So when you create, it's true. Between the computer nodes, right? So you basically like get priority when you get the situations. You automatically create all the full mesh tunnels.
We create the full mesh channels only with the location, if the location is appropriate, right? We don't do conversational learning, right? We don't want to learn and then program, right? As I said, this is the first cut, make it work. At this point, it's proactive, meaning we don't want to wait for the traffic to begin to start flowing, right? So we learn the location, and it's only one tunnel, right? It's not a big deal, one tunnel. But the real thing which we need to really improve there is the flow program, because we kind of program all once we learn a VM, we program the attached MAC on all the node which is participating in this tenant. We do it, right? So yes, flow will be a lot of flows, but you are guaranteed it's going to work because it's all pre-programmed, right? Those are the improvements that we and you who are going to participate and who has complaints about a lot of flows, come and help us fix the issue, conversational learning. Let's do it. I mean, let's do it, yeah. But this is just an entry into the world of integration, really.
Cool. I think that, I mean, unless there's questions, I mean, I think that's about it, right?
Yeah, that's about it.
Does anyone have any final questions or?
We all hang out in the OpenDaylight-OVSDB IRC channel, and we don't send a lot of emails really because we don't have the patience to send emails. So we all there chat, and get things done. So send emails to OVSDB dev, and we'll point you back to the IRC channel. So please come to IRC and let's hang out, and it's really fun, more fun there.
Yeah, definitely. Okay, well, thanks everyone. We appreciate it.
Thank you.
Thanks. So we're going to be handing out USB keys to everybody that has the VM images. Madhu, do we have about 70 of these left, or? Yeah. Yeah, actually, if you need a USB key, you don't have the images, raise your hand maybe, and we'll pass them out. Yeah. Yeah. Yeah, and then once you, actually, it looks like a lot of people already have them, but we'll pass them out here. We'll get them around. There we go. He's tossing them. So we'll kind of wait till everyone gets a USB key here, and then we'll get started on this as well. There's a couple of seats up front here if people, if anyone wants to come and sit down up front. You don't have to be shy. Ryan doesn't bite. He's okay. You never know. Okay. Okay, so we'll kind of get started here. I usually like to wander around when I talk, so this is going to be difficult for me to just stand here, I guess, a little bit. But so welcome to the second. Oh. This is better. Okay. So welcome to day 2 of the OpenDaylight Summit. It's kind of interesting that they put this tutorial right away in the morning on the second day after the party last night. So, but this will be pretty good. So hopefully everyone's here to learn about using OpenStack with OpenDaylight. So the team of people that have been working on this have been working on this for quite a while now. So hopefully everyone gets a good idea of this. I just put 4 of the names of the people that are going to be helping out. We already copied these over. So we'll go through this kind of slow to make sure that everyone gets that. I'm going to boot the control instance first that I have here. So this will boot relatively quick here. So everyone else, is everyone else booting their control instances as well? Yeah? Okay. So this is up. Going to log in as, the login information for this, by the way, the username is ODL and the password is ODL as well. And it is set up for sudo access as well. So I'm just going to take a look. So in my case, yeah, this one was already configured as well. Okay. So how many people have their control instances booted up already? No one? A couple people? Okay. How many people are still copying the images off of the USB keys? There's a lot. Okay. Login is ODL, and ODL is the password as well. Just a sec. Let me bring up the slide. I think there's, yeah. I'll leave that up for a sec. So that's actually, wait a sec. That's actually incorrect.
And for those who have trouble copying the image over, the USB has been formatted with exFAT, so you may have to install that driver.
For which operating systems?
I mean, XP doesn't support it. Yesterday we saw that, and it has problem with Ubuntu now. So. Yeah.
Oh, Ubuntu had a problem as well with? Okay.
Yeah.
Okay. Okay. Yeah, if anyone's having trouble or anything, raise your hand as well, and we'll get someone over. Hey, Brent, could you? Got it. Thanks. Okay, so maybe while we're waiting for everyone to copy the images and bring up the control node, let me go back to these slides over here as well. So logistically, where is this right here? Okay, I can't wander around now. This is this is a high-level slide of what you're going to have to change on the OpenDaylight slide image as well. So as you can see here, we've put OpenDaylight in the image as well, and it's the released virtualization edition of Hydrogen as well. Inside the ODL, as we're going through this, these three people will be doing that. So actually, Ryan, could you raise your hand so everyone sees you? Brent and Madhu, you guys are at the back, right? Raise your hands. So if people need help as we're going through this, these guys are going to kind of wander through, and we'll be able to assist people with things as well. So, okay, let's see. Let's jump into things here. Okay, so this is kind of what I hope everyone walks away with from this presentation as well afterwards. So actually, first of all, a show of hands. How many people have experience with OpenDaylight? How many people have brought up OpenDaylight a little bit? Okay, so that's not bad. How many people who raised their hands brought it up yesterday during a tutorial for the first time? Okay, so there's not a lot of experience there. Okay, what about OpenStack? Does anyone have, how many people have experience with OpenStack? Okay, so there's a good experience. So this tutorial will be somewhat high level, I think, depending upon, but you can go deeper if you want as well. So we're going to give everyone experience bringing up OpenStack, OpenDaylight on Fedora, Linux as well. That's what the VMs that are on the USB keys have as well. We're also going to give people experience bringing up a multi-node OpenStack environment using DevStack. And then hopefully you get some experience seeing how the two of them integrate together and how OpenDaylight is able to orchestrate virtual networks for OpenStack Neutron as well. Okay. So really this is as simple as it gets right now. We're going to have two VMs. One of the VMs that you're going to use will have OpenDaylight running in it, as well as the OpenStack control software and OpenStack Compute, Nova Compute on it. And the second VM will just be running Nova Compute as well. And this way we'll be able to see the tunnel network set up for the tenants and everything like that. So, okay, everyone has the USB key? So let's plug them into your machines and copy the files over. The other thing you're going to need is either VirtualBox or Fusion or Workstation or KVM or something like that.
There'll be two folders in that stick. This tutorial is for on the DevStack only.
That's a good point. You can hold on to that one. I'll stay up here. Okay, so I'm going to try to do this as, whoa. Interesting. Ah, there we go. That worked. Okay. So I've actually directory. There's an ODL directory and then an OpenDaylight. And inside there's a configuration directory, and there's a config.ini file as well. Okay, that's a little. Okay, so one of the configuration items that you're going to want to deal with is the OVS DB support that's in OpenDaylight supports both OpenFlow 1.0 and OpenFlow 1.3. And I think that this was discussed yesterday at one of the sessions, although Madhu will correct me if I'm wrong, but I think, did you discuss the a little? Okay. I mean, at a high level, the differences are OpenFlow 1.0 will set things up to look exactly like the Open vSwitch Neutron plugin, or the ML2 Open vSwitch mechanism driver as well, where you will have two bridges on the host, a BR-int and a BR-tunnel, and you'll have patch ports between the two and things like that. OpenFlow 1.3 does things a little bit more intelligently. It uses a single bridge, and it uses multiple tables on the bridge to handle the tunnel traffic. So that's a configurable option in there as well. And then there's also, you can configure an IP address if you have like a multi-homed host as well. You can set that up in there, so OpenDaylight will bind to a specific interface as well. If you log in as ODL, there should be an ODL directory, I think. And then in there is, or is it, do an L, hold on a sec, I'll do this. Did you find it? Ah. Actually here. If you see here, so I'm logged in as ODL, so there's actually an ODL directory in there. I think this should be pretty readable. So inside OpenDaylight, that's the unzipped released version. Yeah.
How do you increase the font?
Yeah, actually, hold on. I'm going to actually do this. That's a little better, Madhu? Yeah?
Yeah, seems okay.
Wait a sec. I just need to see what that IP address is. I'll log in from over here. There we go. Yes. 133. Yeah, there. Okay. This should be a little bit more readable. Okay. So you can see in this directory here where the OpenDaylight would be untarred if you download or unzipped if you have it there. There's the configuration, and then there's a config.ini file. So inside of this is where you'll see the version. So it defaults to OpenFlow 1.0, the OVSDB support inside of OpenDaylight. You can uncomment this to do 1.3. I think that this is actually uncommented by default. I think, is that correct? Yeah. Okay. Thanks for verifying. So then there's a run.sh lowercase script here as well, which actually is what is used to start OpenDaylight. I've actually created a capital run.sh that actually has both versions as far as the command line parameters to start this. I think that this should be, you want to make sure that this OpenFlow 1.3 is uncommented. Yeah. Did you have something to do or no?
No.
Okay. So once you do that, then we can go ahead and bring up OpenDaylight by running this. And so then we'll let this will spin for a second as it boots up. So just a show of hands, how many people are at this point as well? Is anyone here, or are people still copying things over or bringing up VMs? Okay, a few people. Yeah, 1.3, leave that one uncommented, yeah. And then make sure you also have in the configuration, config.ini, the 1.3 uncommented as well, yeah. You can change those. I think Madhu was saying that by default, it's fine to leave it on and let it bind everything at this point, yeah. Otherwise, you could set it up to be the second interface. So the way that the VMs are set up, depending upon if you're using VirtualBox, Fusion, or Workstation, the first interface on the VMs is typically going to be the NAT interface, so it'll be NATed. And then the second one is set up as a private network on the host. So typically that's what we'll use for this communication, but either way it'll work.
Just in case, right, for VirtualBox, we had some problems yesterday when we were running this demo.
Okay.
So try to avoid NAT as your any communication for it, right? So just use, if you can create two host-friendly networks on a VirtualBox, and use only host-friendly networks for this.
Yeah.
Don't use NAT.
Don't use NAT.
Don't use
So if you're using VirtualBox, don't use NAT.
And you create them under preferences in the global config, not in the actual VM itself. Just in case anybody's fresh to VirtualBox.
That's for VirtualBox, Brent, or?
Yes, sir.
Okay. Okay.
We learned painfully yesterday.
You learned painfully.